Hey everybody, my name is Tony Ucita Velez. I am the CEO of Versprite, and welcome to a special edition of Cooking with Pasta. Tony UV, CEO at Versprite, to begin this Cooking with Pasta series. So stage one is understanding your business objectives. In a risk-centric approach, you have to understand impact. It is one of the delicious ingredients that goes into any risk methodology or risk formula. So much the same in pasta, we have to have context. And there's a saying at Versprite that we say all the time, which is context is king. You have to understand, how is this product or software that you're making, how is it going to make your company money? Or how is it going to help maybe facilitate processes within your organization if it's a back office application or an internal application? There's all different types of applications in the healthcare, financial, retail space, and they all have different goals. Some of them are for payment processing. Some of them are for providing medical information with high data integrity to physicians. Other might be maybe financial data meant for providing analysts real-time access to financial information so they can make real-time decisions. You have to understand, what is the purpose of your software, right? Much like cooking delicious pasta. I might be wanting to cook pasta for myself. I might be wanting to cook pasta for someone else. Those changes the objective, maybe how I go about doing things. Or, in a better example, what happens if I'm actually trying to start a new pasta company where I have to think about scaling and I have to think about maybe costs of goods sold and global manufacturing. Different goals will actually affect my inherent impact considerations in pasta as a risk-centric approach. So we have to understand, as a software developer, an architect, an engineer, what are some of the things that I care about because the company cares about it? It could be uptime, it could be downtime, it could be trying to stay away from regulatory requirements and lawsuits and things like that. So it's so important to begin with that level of context. Now, in the application software development space, there's other types of considerations related to things like standards and regulations that might be a business objective as well. So making sure that you address those up front, right? So I'm making an analogy to cooking with pasta. If I'm cooking for myself, maybe I'm happier with just a simple, thicker style of pasta versus maybe a thinner style pasta for that's gluten-free for a significant other, as an example. Those types of considerations really impact the type of software that you're going to threat model. And context is king in risk-centric approaches. So you might be asking, well, what do we actually use to capture this information, right? What you use is simply, the discovery process is interfacing with the product owners, more people on the business side of things, right? That have some level of skin in the game for that software product that's going to be, on the Apple Store or on the Android marketplace or as a SaaS offering to millions of commercial companies worldwide. Being able to understand, what is the financial projection and goals? What is the requirements for uptime and downtime? What are the regulatory landscapes that I'm actually having this application live in? These are all super important contextual things that go as ingredients into beginning with pasta in stage one, which is defining your business objectives. Stage two, technology enumeration, which is trying to understand, what is the technology behind our application? That is the main goal of stage two. It's an enumeration exercise where we understand, are we dealing with third-party libraries? Are we dealing with code off-the-shelf software from a third party? Are we dealing with, what is our operating system stack? Are we using, what types of microservice technology are we using in the cloud? So as a metaphor, when you're cooking pasta, you have an array of different ingredients, right? You want to make sure that you select certain types of things like, good quality eggs, good quality fresh cheese, ripe tomatoes straight from the vine, and things like that. This is a metaphor to choosing the right types of ingredients that goes into your application threat model. Typically, when you do application threat modeling, you don't really think about what am I working with. In PASTA, the process for attack simulation and threat analysis, it's a major, major component because as you're building a threat model for your application, you want to be able to look at and understand what is the technology that you're running, right? And so later on, we'll see what are the associated vulnerabilities of the technology that you're running. What is the associated user permissions that those maybe process IDs are running, maybe with an elevated context? What are the associated attack patterns or live exploits that are running out there that are associated with your ingredients? So technology enumeration, both with raw ingredients, also with equipment, we want to be able to understand what is the type of technology that you need in order to build, maintain, and deploy your application, because all of those different things could be an avenue of attack and exploitation. So let's take as an example a mobile application. Mobile applications is client software running on Android or iOS, tying into a backend mobile API. A lot of times when we do threat modeling for different clients, we're looking at a threat model unique to the client to look at client-side attacks, but we're also looking at attacks to the mobile API endpoints. We have to understand what is behind the mobile API endpoints. Are there any interfaces with content partners or technology providers that might be providing, let's say, their own flavor of JavaScript or marketing analytics to capture, different use cases in the application model? It's important in stage 2 to enumerate what is the technology stack of your application, what are the use cases supported by your application, and in stage 3, we'll understand a little bit about what is the privileges and the data flow. But it's important that you understand what is the attack surface for your applications. And in stage 2, that's what that is all about. All right, we're back for stage 3 of PASTA. This is application decomposition. This is where we get into some of the fun stuff with data flow diagramming and things like that most people who are experienced with threat modeling may have already heard about. So in front of me, what I've done is I've added a lot of ingredients. And this is kind of a metaphor for stage 2 and stage 1. We have ingredients in the business context. What do we care about? What regulatory environments is our application operated in because of the data that it has, the data model? We also want to look at what are the ingredients of the application itself, right? We want to understand a little bit about the software that is running, the open source software, the commercial grade software. We want to understand a little bit about the use cases and stage 3. And those use case considerations is really what's going to basically make everything come together. Much like, the dough that I'm trying to knead over here and trying to get it ready so that we can start cutting pasta. So there's a lot of things that go into making great pasta for risk-centric threat model approaches. In this stage, you want to really understand how does the technology stack receive information? What is the access control model or the authorization model of users within your application? So any application has users that run a process or that interface with the application. You have to think about in this stage how it all comes together. How is authorization done? How is authentication granted? Are you using OpenID? Are you using Auth2? Are you using OAuth protocols? What types or frameworks better said? What are the types of things that are going to support all the different use cases? Here's a very specific one: file upload. So you might have a use case within your mobile software. You might have a use case within your web application software that allows users to upload a file. And so you want to be able to understand what happens to that file within the application model. How is it ingested? How is it verified for integrity? How is it passed along the different components of the application environment? This is what application decomposition is about. Is being able to produce data flow diagrams that show calls, application call flow, and then also it also shows a little bit about what are some of the privilege models that goes along with that application call flow. So a lot of the technology that we've enumerated in stage 2, we can actually depict in various types of data flows. We might be in AWS and showing how AWS components, S3 buckets, EC2 instances, Dockerized environments, or Kubernetes pods that are running XYZ service within our application model. What is their overall data that they need? Is there even application configuration data that's remaining statically there that could be a risk to the application model? Is there an authorization model that's outside of the entire cloud environment? This is all going to really come to life once you start to dissect all the ingredients, put it together. And for those that are wondering, well, who gets involved in this stage? Architects. Architects, developers come together. So you have developers that are working on your UX, your presentation layer, developers that are working on backend, developers that are working on server-side components, maybe third-party developers. Invite them to the table for threat modeling sessions with the architects. So there's a holistic conversation of understanding function so that later on in PASTA, we can understand dysfunction. Remember that PASTA stands for Process for Attack Simulation and Threat Analysis. So stages 1, 2, 3 are all about function. What do I care about? What am I working with? How does it come together? In stage 4, we're going to look at now what could go wrong with my application, right? There's a lot of things that could go wrong in making pasta. You could have a breach where the egg basically goes beyond the borders of the little funnel that you built in the flour. You could be using bad ingredients. You could have, other problems with the equipment that you're using. But we're going to talk a little bit more about that in the next stages. Stage 4 is about threat analysis. This is about thinking about what threats could obviously affect the application. Now, one of my pet peeves is that those that do threat modeling never consider threats, right? They look at maybe static threats, threats that don't change. There's different types of threat categorization models that are out there, and they never change. They were the same 20 years ago, 10 years ago, 5 years ago. Threats change every single year. So why use a categorization tool or matrix that is actually going to be static? Your application isn't static. Your technology components that go into the application are not static. So in this stage, we're going to think about all the ways in which good threat intel, good threat data could actually improve our own PASTA threat model. So let's begin from a threat intel standpoint. Threat intel in the book that was written many years ago, 2015, it is about looking at what outside threat advisories are out there against components. Remember stage 2, we had our ingredients of our application. Maybe there's threat advisories for code off the shelf for software that is in your software, right? And so open source libraries, okay? Maybe some dependencies on third-party software services, SaaS-based services that might be vulnerable to attack. You want to be able to reconcile those threat advisories to your own model, right? To the own technology that you have. And so let's say that you find some good threat intel that relates to advisories against the use of Apache or PHP versions. And there are actually a lot of active exploits that are creating denial of service because of a vulnerability in PHP. And there's a threat advisory showing that there's a lot of exploits in the wild. So the first thing is obviously to reconcile your threat intel with what you were working with in stage 2 of PASTA, which is technology enumeration, aka defining your attack surface. So with good threat intel, you can see, does this affect my application or does it not affect my application? Another source of information as an ingredient that you want to use is to be able to use threat data. Now, threat data comes from within your organization. You might have web application firewalls, endpoint protection software, different types of preventative or detective software or physical appliances that are stopping attacks. And that data is threat data, and it can be used to say, hey, we have a problem here. We have a problem in our DMZ or in a cloud service provider where an increased amount of attacks of a certain type have actually happened. Brute force attacks, authentication bypass attacks. The whole environment is telling you something. Take that data as an ingredient in pasta to basically identify what possible threats match with a threat library that you want to create. Now, threat library is the most important output of stage 4. You want to create a list of threats that pertain to your application. So let me go into financial services. Let's say that you're a fintech company that is providing a business-to-consumer card, and you are relying on a third-party provider to provide maybe banking information for your customers as part of that B2C fintech product that you're offering them. Well, that interface might actually be using a protocol that might be vulnerable for attack. It might be maybe something that is wrong with the actual endpoint, the API endpoint, the technology endpoint that could be exploited, that could be thereby leveraged to go into your application model. In application decomposition, one thing that we didn't really spend too much time on is trust. In this example of a fintech application, you might be trusting a third-party service provider with data and implicitly consuming data or whatever into your application. And so that implicit trust, coupled with maybe a threat advisory on a technology component in their stack, could actually spell a threat or attack vector that you may want to consider. So at the end of the day, threat analysis is really being able to build a threat library, define what are the possible threats that could affect your application. It's not always about data compromise. Oftentimes when there's threat modeling evangelists that are out there, they focus on the data. There's a lot of industries that they don't even care about the data. Utility sector is one of them. Sometimes it's about continuity, and continuity is king. So it's not just about data security, it's about service continuity. It could be about data integrity. Think about healthcare. Doctors making decisions real time. They need accurate information on patients in order to make a decision that could affect their life. Integrity is key. So those sort of things, confidentiality, integrity, availability, would be rooted in stage 1. What do I care about? Do I care about integrity? Do I care about data protection? Do I care about availability? Reconcile that to the threats that you are developing as a threat library. I'm concerned about extortion. I'm concerned about information compromise. I'm concerned about someone living in my application environment, right? And just setting up shop and squatting in there and consuming memory resources, processing resources, etc. The list goes on and on. So build a threat library custom to you, add in the ingredients of a threat intel, find good threat intel, much similar to adding good flour, good cheese, good fresh tomatoes, good eggs, and then also threat data. In your own corporate environment where you're hosting these applications, you're going to have systems that are sharing important information that could spell threat concerns for your application. So that's stage 4 in a nutshell. We're going to move over to stage 5. Stage 4, threat analysis. Stage 5 is vulnerability analysis. Here we're trying to understand what vulnerabilities could map to our threats that we've identified in stage 4 that could actually give way to the objectives not being met in stage 1 from being fulfilled. So let's look at a metaphor with pasta. So in front of me, I've been rolling this pasta dough for a little bit, and we think about vulnerabilities in what could go wrong in cooking, what could go wrong in making pasta. You could maybe spend not enough time in having rolled the pasta dough, the actual dough, and you could have spent more time maybe having a breach that we talked about before, where you have the eggs going through the walls of your flour. So the metaphor here is we have ingredients that we've brought into making pasta, the flour, the eggs, etc. But there's things that could go wrong in the whole pasta making process. Similarly, in your application, there's a lot of things that can go wrong as you're developing software, as you're deploying software, as you're engineering infrastructure and configuring the environment. So those are some examples where things can go wrong just purely from a configuration or code weakness or code flaw standpoint. In addition to that, you have things that could go wrong with things that you didn't even author as a software engineer, as a developer. You might, for example, get third-party software. And third-party software might be like this egg. And if the egg basically had some sort of like integrity flaw, then it might not be good to mix into your product that you're actually trying to build. Similarly, open source libraries, JavaScript frameworks that might be vulnerable to different types of attacks, new exploits for even authorization or authentication models that you might be using outside of your application environment. You want to be able to make sure that you have those threat advisories, they get factored into your threat model, and then that you address those vulnerabilities. And this is where we start to build the attack tree. Really, we should have started building the attack tree in stage 4. Now, you might say, well, why are we building an attack tree during threat analysis? The attack tree is an output that basically maps in a tree-like format what is the top threat that we're concerned about, and what is the ingredients that we enumerated in stage 2 that could be affected. Maybe those ingredients have vulnerable software. This is what stage 4 is about. We're trying to take existing processes within our security program that are looking at code imperfections. Maybe we're trying to look at software composition of our environment to see if there's supply chain issues with insecure products that are in our overall infrastructure. Maybe we're looking at vulnerabilities that are pertaining to the platforms that we're using. So we can use a lot of things today, that are part of a security program, such as vulnerability management activities, static analysis or linting activities, dynamic application security testing, pen testing. We can use a lot of those pre-existing things that have been found before as we're looking at vulnerabilities and say, what known vulnerabilities do we have now that have been shown to be associated with the components that we identified in stage 2? Again, technology enumeration in stage 2, aka attack surface. So vulnerability analysis is, what are the vulnerabilities and weaknesses that would give rise to the threats in stage 4? Let's put on the chef hat of a criminal for a second. Let's say that I want to steal your money. Let's say that I'm a hacktivist and I want to subjugate a particular municipality that, for whatever reason, I don't agree with their political campaign. And I want to really make sure that their online presence is non-existent. So based upon those adversarial threat goals, how am I going to do that, right? What vulnerabilities do I need as a bad chef to be able to realize my threat goals of stealing information or bringing you down? So as we start to look at this risk-centric approach, we start to see how it's all working. Everything is contextual and building off of the last stage. What do we care about? Stage 1. What are we working with? Stage 2. How does it come together? Stage 3. What are the vulnerabilities? What are the threats that are actually affecting our product or service that we're building based upon intel that we get from the communities or from within our own infrastructure? And then what are the vulnerabilities in stage 5 that map to those threats that will give way to those threat goals? So stay tuned now as we start to build out this threat tree. The threat tree right now looks like a parent node of a threat affecting a component as the underlying layer. And then now we have these layers of vulnerabilities. What are the vulnerabilities that are affecting those components within our application environment, our software? And then as we go into stage 6, this is where we get a little bit more hands-on by attacking the application or having someone attack the application to see if there is some level of viability of bringing a website down for a particular municipality or stealing information for a fintech application software product. So stay tuned for stage 6. We're going to dive further in. We're going to build out further our attack tree. And by then, this big flattened piece of dough will start to look a little bit more as cut up strips of delicious pasta. Stage 6 is attack modeling. Now getting some formation in terms of like fettuccine style pasta that's fresh. I can't wait to dig in. But let's first dig into attack modeling, stage 6 of the process for attack simulation and threat analysis. So stage 6 is really about talking about the viability of attack.
to what degree are attack patterns viable based upon our application model, based upon the architecture, based upon the vulnerabilities that we found out in stage 5. Stage 6 is adding new layers to that attack tree that we just built, much like maybe adding bits of flour to our dough so that the dough doesn't dry out, which reminds me I have to add a little bit more here to my cut pasta. But going back to attack modeling, what we want to do is we want to be able to add on attack patterns. And the great thing about threat modeling is that you can leverage industry taxonomy of terms on attack patterns, vulnerabilities, stage 5 again, or threat intel, stage 4. With stage 5, we have the opportunity to look at vulnerabilities, and when we think about vulnerabilities in the security industry, we have an opportunity to rope in things like common weakness enumeration lists or common vulnerability enumeration lists, right? CVEs and CWEs. I like an attack tree that has CVE, CWE, little identifiers as part of vulnerabilities that are in my growing attack tree for a particular threat. If I'm beginning with a threat on extortion, I'm going to see what components in my application, stage 2, are affected and what associated vulnerabilities, CVEs, might actually give rise to that threat on information disclosure, credential compromise, etc., etc. Stage 6 is about what types of attacks could be conducted against those vulnerabilities, assuming that the attacker or the threat actor has direct access to that affected component. So here we start to map in things like KPEC for MITRE. It's a library of attack patterns, or we could even map in the attack ATT ampersand CK post-exploitation framework list, where we have layers of attacks that are in our attack tree. So imagine, if you will, again, a parent node of a threat that is affecting components that is tied to vulnerabilities, that is tied to attack patterns. We start to see, the attack tree, become fuller and fuller, much like a delicious piece of broccoli, as we continue with the cooking theme. But attack patterns is so important, and it's such a beneficial component to break into our threat modeling methodology, because now we're trying to think, is this attack viable? Does it lend credence to threat likelihood, right? We could actually give our attack tree, give it to a well-off, knowledgeable pen tester, and they can look at the attack tree that we built up until now as a blueprint for trying to exploit the application to see if there's some level of credence to the threat concerns that we have in our threat model. Now, from a bigger perspective, let's say that you're looking at this cooking with pasta tutorial video, and you're thinking, you're coming from the point of view of a product owner, right? You want to know all these different security things that are coming at you. What sort of things should you really look at first? This is the whole point around pasta. It's a risk-centric approach. If you have an attack that works against a vulnerability, stage 5, that supports a threat claim or within the threat library, stage 4, that is launched against a technology component or software in stage 2, you start to see, okay, I'm using this component, it's vulnerable, it fell victim to an attack, and it works. And it goes against the things I care about in stage 1, which is either continuity, or maybe regulatory compliance, or maybe it is related to not having information disclosure. And et cetera, et cetera. You define those business objectives. We already went over those in stage 1. So this is about bringing it all together. So much like this stage right here, where I'm actually taking a knife, I got my sheet of dough, I'm carving out my slices of dough that I'm going to run through my roller, I'm going to run through my cutter over here. We're trying to basically put things together. And this is what this cooking metaphor is all about. It's putting all these different ingredients together to show a point on a risk-centric approach to handle the most likely and most business impacting flaws that could affect your application. Now, stay tuned to stage 7. This is where we finalize with countermeasure development, and ultimately residual risk analysis.
Stage 7 is residual risk analysis and countermeasure development. This is the stage where we finally look at the residual risk around all the things that we've identified, culminating up into stage 7. So we've looked at what is important to us. Stage 1, business impact analysis. We looked at what is the technology that we're working with? What are the pieces of data that we're working with? Stage 2. Stage 3 was about how does it all come together? How does our application use cases supported within the application model leverage some of the technology components that we've enumerated in stage 2? Stage 4 is threat analysis. We've added those ingredients as a vital and important part to threat modeling. And in a risk-centric approach, we're really looking for threats that could realistically happen based upon good threat intel and good threat data. And then we had stage 5, vulnerability analysis. What vulnerabilities to the components that are supporting our technology and our product identified in stage 2, what are the vulnerabilities associated with that, or what are the weaknesses? This is where we start looking at CVEs and CWEs and start to build out our attack tree. Stage 6, attack pattern considerations. What types of attacks would actually undermine our application based upon the vulnerabilities that we've identified, vulnerabilities as well as what types of attacks actually map really well to the threat objectives identified in building out our threat library in stage 4. Stage 7 is how does it all come together? So as we look at our attack tree, one of many artifacts that is produced in threat modeling, as we look at that deliverable, we start to think about, well, do we care about if a session hijacking flaw is actually realized in our attack tree that we have identified? And if it maps to a vulnerability that supports a threat goal that's tied to an asset, and it reconciles to a business objective that we've defined in stage 1, you can bet we will care about it, right? Because this is a risk-centric approach. At the end, stage 7 is really about reconciling the key business goals or product goals or service goals that we've identified in stage 1 to the things that we found in stage 4, 5, 6, right? So all the different possible threat scenarios that have associated vulnerabilities that would give way to them, or attack patterns that would give way to them, would now be tied to the business objectives that we define for the product. Risk analysis, especially residual risk analysis, is looking at what is the leftover risk that we're going to sit back with as a product owner, as a software owner, as a service owner. This is in consideration of even some of the countermeasures or protections that we have. So let's say you're running a web environment and you have a web application firewall. You might think that you have some level of mitigations to some of the things that you've identified in stages 5, 6, and now 7. But the fact is, do you know the effectiveness of that web application firewall? That would have been tested in stage 6 as you're running active exploits against your web application dynamically, maybe through manual abuse patterns and fuzzing and parameter fuzzing and things like that, so that you find whether or not your web application firewall was actually effective. So residual risk analysis is like understanding what is left over. And this is basically a plate of information that is really relevant, contextually based, and means something to so many different people. It means something to, most importantly, the product owners. There is no denying the threats that have been evaluated, the attacks that have been correlated, and the vulnerabilities that have been associated to the overall threat model, so that you understand as a product owner, I actually have a vulnerable product that could be recalled, that could actually land me in a courtroom, right? Or that could, even worse, make my company be on the front page of the news. So residual risk analysis is really about the net of all the things that we've done up until now. It's basically the delicious final dish served. And what it helps to do is depict for the product owners what are real issues that they need to worry about. It might have some takeaways for architecture. Maybe the overall application design needs to be better. There might be vulnerabilities in the, for example, authentication model, the authorization model, maybe any sort of audit trails. A lot of these things, architecture might have some weigh in on. There might be vulnerabilities or weaknesses in the actual code itself. maybe there's some implicit trust between software class objects that are passing along parameters and information that are being used by methods or class objects without any level of inspection, right? And so this overall threat model might be very beneficial to developers. Engineers are building infrastructure to host and manage a lot of the applications of today. And so they might better understand what are the infrastructure related vulnerabilities or weaknesses that are related to third-party software and products or service providers that are undermining the objectives of the overall product and service being provided. So I'm going to dig into this delicious plate. This is the culmination of our effort. Homemade pasta, freshly grated Parmesan cheese, ripely picked tomatoes, farm to table, and an ample amount of your favorite vino. I'm going to dig in. I hope you dig into this video and hope that you have some good, tasteful takeaways so that you can adopt pasta as a risk-centric threat modeling for your secure software development lifecycle program. Thanks for joining.